So when $1,200 was invested into an account for 15 years, let's just start writing. There we go again. You're like, oh my goodness, I get it already. I know, I do too. It increased to 23.5387. The rate of interest was compounded monthly. Okay, that's good. Well, they didn't tell me the interest rate. Oh no, but I do know it's monthly. Okay, this one is different. So if you were like, man, I got it already, let's move on. We're moving on. A equals P, 1 plus R over N to the NT. I know I'm writing fast, but we're about to plug in all these numbers and we're going to have the variable in a different place than it has been. So 23.5387 equals 1,200, 1 plus R over 12, and we're going to raise it to the 12 times 15. Okay, there's a lot going on here. Let's divide by 1,200. That's going to cancel those out. And that's going to leave me with, well, I normally could simplify this, but this time I can't. So I'm just stuck with 1 plus R over 12 to the 12 times 15. Well, in case no one ever told you what that is, that's 180. And on this side, we have 23.5387. And I got a crazy decimal, 1.961558333. It might keep repeating, don't know. My guess would be that yes, it does. And I'm going to use all those decimals, but now I'm not going to use a logarithm. I'm tempted to, but I'm not going to, and here's why not. I'm raising something to the 180th power. I'm not solving for a variable that is in the exponent. I am solving for a variable that's, well, not in the exponent. It's down here. So I got to get rid of that exponent. So we're going to take the 180th root of this. 180th root of that. Oh boy. It's going to get fun. Okay, so on this side, the 180th root cancels with the 180, and so I am left with 1 plus R over 12. Well, on this side, I have the 180th root of 1.96. So let's do that. Actually, that was the last thing I typed, and I want the 180th root of it. Check this out. We're going to raise it to the 1 over 180. It's the same thing. An exponent of 1/2 is a square root. Exponent of 1 over 180 is a 180th root. So 1.00375. I'm going to stop writing there. I'm going to carry the 0009 with me, although I really doubt it's going to get me too far. All right, so let's subtract 1 from both sides. Solving for R. R over 12 equals 0.00375. So we subtract 1. And then we're going to multiply by 12. Getting rid of that 12 in the denominator. And that leaves me with R equals 0.0450000134. And maybe this is important in some other world, but not right now. Because they're asking for a rate, which would be a percent. So this is going to be sufficient. When we get down to here, it's just too far. So the rate is 4.5%. We've moved the decimal 2 places. All right, last one. Peyton has a savings account at First National Bank that earns an annual interest rate. Annual interest rate, let's just start writing. Good stuff to know. Annual is 1 time a year. That's going to make life easy. The table shows the amount of money in her account each year. Write the equation that represents the amount of money in the account after T years. Okay, well, we also know the original amount, right? That'd be 1,200. We're assuming that she's not putting any more money in. Okay, that should have been stated in the problem. Otherwise, that would really mess up our calculation of these things. So how about we go about this in a really, really easy way? So here's what we don't know. We don't know the rate. So we can start listing stuff we don't know. We don't know the rate. And we are supposed to write an equation that represents the amount of money in the account after 2 years. But in order to figure out something, we got to start listing other things we do know. So let's just go for the easy ones. I know that after 1 year, the amount is $1,254. Okay? So why do I pick that one instead of these? Well, it's going to be easier. I mean, you can pick any of these down here you want to, but trust me, going from here to here is going to be much easier. So let's write the equation. A equals P, 1 plus R over N. Now, let's not lose sight of what they're asking us to do. They want us to write the equation that'll represent this when I figure out the rate. I got to know the rate first. I needed N, got N. I need to know P, I got P. I don't know R, right? So by the time we're done, we're going to have, the amount that Peyton has in her account is $1,200, and then 1 plus whatever we're about to get for the rate, and we're going to divide it by 1, and we're going to raise it to the 1t, some unnecessary ones. This is sort of my final answer. We're going to clean that up in a minute. So I'm aiming for this. Okay, that's why I left that gap there. All right, let's keep going. So use this information to find R. So 1254 equals 1200. 1 plus R over N to the 1 times 1, that's 1 times 1. There's a lot of unnecessariness in there. Let's go ahead and divide by 1,200. I'm not going to show that work. Just 1254 divided by 1,200, and that's going to be 1.045. And I have 1 plus R over 1 to the 1. It's to the 1. That changes nothing. So R equals 0.045. Same answer as the last one, huh? So the rate is 4.5%. Okay, good to know. That doesn't answer the question. And what we're going to do now is talk about the fact that the lights just went out on me. Oh well. So I know the rate is 0.045 as a decimal when I move the decimal 2 places. So this is not wrong. It's totally fine. But, just to simplify things a little bit, let's say that if I wanted to figure out Peyton's balance at any given moment, assuming she hasn't put any more money in, then I would just figure out what this is. That's pretty easy. That'd be 1.045. And it's to the 1t. So her balance at any t value is given by this equation right here. And I can crank out these exact same numbers by plugging in like a 4. Now, it'll be rounded off a little bit. Or plugging in a 3. So that works.